All right. So you guys do remember that we had a lesson on all those properties of limits, and then we had these limit properties we had done. Well, these definite integrals have some properties. They're not, for what I have, it's not as many as what the limit properties we did. One of them is that if I do this, no? If I do this, if I switch the upper and lower limits, what must I do if I switch the upper and lower limits? I what? Put a negative. Okay. Integral from a to b of f of x dx is just the area under a curve. So from a to b, say this goes like this, and we're doing it from a to b. Okay? And so we got this area here. I could break it down into many different bounds. I could go and incorporate and say a to c, that the area from a to b is the same as area from a to c added to c to b. I'm just breaking it down. So yes, I can go ahead and because the area, no, we can just go, and not just that, we can go 3, 4, 5 more, break into pieces, no. So I can say a2, and then this is b over here, and then this is f of x dx. This is f of x dx, and then I can just incorporate that constant here, because now I'm going the area under of this f of x curve, which is f of x, and I'm going from a to c, this area from a to c added to from c to b. Makes sense, no? Sure, why not? I can just do from a to, and just keep breaking it out if I wanted to. Well, but we could. If you have a constant, this is a constant in front of the function. No, c dx. Hold on. C, and then I got dx. All right. This is basically, this right here is the one I told you about, driving at a constant velocity, no? Say this is x, and then this is velocity, v, and then, so you're going at a velocity, constant velocity of what, 60? 60 miles an hour? 60 miles an hour. So this just says that c is your constant velocity, and this will be dx. So this will be a constant, c. C is 60 times that dx. So then this becomes what? That would be what? C times, that's just a constant, dx becomes x. And that would be the integral. Oh, but you know what? I'm doing too much. The constant just comes out. That's all they want. You can take out the constant a to b and keep that dx in there. So the constant comes out of the integral. It's just a constant. You can always take that. And it becomes b minus a. Don't worry too much about this. This is like whatever. This one. We did this one for limits. Remember we did, and for limits, you almost kind of like distribute this. You got two functions here that are added with the dx. You can have one for this and one for this. So it would break down to the integral a to b of f of x dx. so I guess the dx can distribute into each. And then plus, if it is plus here, the integral from a to b, g of x dx. Okay, it's the same if it was minus. If it was minus, you just put a minus there. I guess that's no. Well, that's the one I was trying to do here. I don't know. Maybe this just gets confusing. This one is just saying that you can factor out the c. Factor out the c, and there'll be c integral from a to b f of x dx. I could have just done this one here, plus or minus. I could have put a minus, okay? Same thing here. I don't know. These are like seem very like natural, like makes sense that it would be. Let's go ahead and do some problems now then. So to really understand what integral is, evaluate the following definite integrals given the graph. All it is f of x dx with these lower and upper bound from 0 to 12 is just find the area under the curve. Area under the curve, add them up between the curve and the x-axis. You're adding that up to that to that. What does the first curve look to be? What does this look to be? Anybody? What does it look to be? Part of what? Half of a circle. So just find the area of a circle and half it, no? So area is what? Pi r squared? Area equals pi r squared. Then get an answer for, imagine that it's still there, the whole thing. So pi, what's the radius? So 4 pi. R, 2 squared is 4. 4 pi. 4 pi. Half of 4 pi. 2 pi. So it should be what? I already got that 2 pi plus. So that's going to be 2 pi. Plus, how are we going to do this over here? Well, this is not calculus. This is geometry. How can we do this? Can we do trapezoid thing here? I don't know. What is this anyway? That's going to be a triangle. Let's do this one. This is a triangle, no? This right here is a triangle. What's this area? This is 2, this is 2, and this is what? 2 is 1. So that's going to be what? 5? That thing is 5? Plus what? This one is just base times height divided by 2. Base, what's that? 4 times, how much is that? 4 times 2 is 8 divided by 2? Is it? It's 4, no? Minus 4. So the answer to this should be 1 plus 2 pi, or 2 pi plus 1 if you wanted to. 2 pi plus 1. You can't really. combine those things. So it'll be 2 pi plus 1. All right. Let's go to 2. What would it be if we go from 0 to 12? Or what? No. 12 to 0. What? We went from 0 to 12. We went from here. We went from here that way. And now we're going to go from here this way. What is it going to be? Could we? I don't know. You could look at that. This becomes what? This becomes positive 4. This becomes. So this is going to become, we said positive 4, that'll be negative 1. And this becomes negative 2 pi. So negative 1 plus, no, negative 1 minus 2 pi? Well, couldn't we just, because we're saying you can minus it. So it'll be negative 1, negative 2 pi, no? Let's go, number 3. If I told you that from 4 to negative 10 of some function, 4 to negative 10, the integral of this is negative 3, and from 4 to 6 of that same integral is 5, then what is the integral from negative 10 to 6 of g of x dx? That's a riddle. Okay, we got it. Eight. I sometimes make it more complicated than it is, but I think I got the simplest, most elegant way of doing it, which I think that's. You're going from negative 10 to 6, no? You're going from negative 10, whatever, to 6. So we want to go, well, just put the negative in front of this. It becomes if you, then you change the bounds, and then this better become what? I think that's the easiest way to do it. This becomes positive. And then we would be going, because this is this. I know it's 8. I know it makes sense. I can't even. But I know it's 8. Yes, it is 8. Sometimes I don't need to say anything. You know how to you yourself do it, no? Yes? But I don't really want to mess you. Let's move on. Go. Let's go number 4. Um, yeah. Let's go. All right. What is it? I think I already got it. I don't know. There's not too much to teach here. It's we already done it. If you know the limit rules, it's the same stuff. It's the distributive, distribute this here also. Factor out the 3, factor out the 5. 2 to 8 of g of x. 2 to 8 of g of x is 18. 18 times 3, 54. This from 2 to 8 of f of that's negative 8. Negative 8 times this. Negative 40. And that's going to be 14. Did I say negative? Yeah, well, yeah. So that's 14. It's 14. I don't know. Let's continue on. This is kind of an easy lesson. Let's see. Let f and g be continuous functions if this. Yeah, they'll probably, these are like multiple choice questions on the AP, I think. Let f and g be. Yeah, whatever. What is this? Yeah, what is it? There you go. I think I got it. Next, another one, 6. What is it? Yeah, yeah, negative 26. Because you're going to get negative 18, then you're going to minus a positive 8, because you're going to become positive 8. Negative 26. Or whatever, yeah. Is this it? Oh, all right. I think we're almost done here. Number 7. Let's go to number 7. If you get this on your own, then you really kind of understand what integrals is about. Who got it? What do you think you're gonna do? Graph it? No, you have to graph it. Graph it. How does what is x minus 4? What is the absolute value look like? It's be shifted to the right 4. So go here. I guess I have like this here. And it's saying the integral from 0 to 6. So yeah, you want to find this area and this area. And that's going to be what? Base times the height divided by 2? 8? Is it 8? And that's going to be what? That's going to be 2, so it's 10. Is it 10? Let's see. Is it 10? Last one. This would be the last one here. All right. Last one. What? So, how would you know that this is a what? What do you think is the shape of this on the graph? Someone say circle? Or am I hearing things? So, I don't know. It's a circle. X squared plus y squared equals c. C is 36 squared. That's a circle. X squared plus y squared equals r squared. R is the radius squared. That's a circle. So we solve. So this is going to be, this is what? Well, 6 squared is 36, no? We already said this is 36. And we solving, what they did was solve for y. The y has been solved. So then you're going to get what? Y squared equals 36 minus x squared. And square root it. And so you're going to get y equals plus or minus square root of 36 minus x squared. Y equals plus or minus square root of 36 minus x squared. But if it is plus or minus, it wouldn't be a function because it's a circle. Then how are you gonna find the area of? This makes no sense. This makes no sense because I'm thinking they undo each other somewhere. It makes no sense, no? Because like it has to be some function, no? It has to be some function, and whatever you can find the area between here and here. So you have to do the positive one. You got to do the positive one. That's why. So So now if it is a positive one, so it's a circle with the radius of 6, center at 0, 0. So if it is center at 0, 0 with the radius of 6, and it's going from 0 to 6, it's going from 0 to 6, we couldn't do the negative one, so it's got to be that one. So it's got to be a fourth of the area of a circle. So the radius is 6, so 36. A fourth of 36 is 9 pi. Yeah, 9 pi. What? There's one more? There's one more. I thought it was the last one. There's one more. All right. Move on. Let's move on to the next one here. Last one here. This has got to be the last one. Number 9. What are all the values of x for which 0x to 2 of tq dt is equal to 0? Who got it? Definitely there's one obvious one. What's the obvious one? Oh, the obvious one is negative 2? 2 is the obvious one because you're not moving. No, you're just 2 to 2. Whenever you have an integral, the same is it's going to be 0. But the other one is negative 2. And why is it negative 2? Also. It's an odd function. It's an odd function, no? So if you go like this, and it's a cubic function, so it goes like this, something like this. So from negative 2 to 2, it will be this, and this will cancel out for the area under. What? No, that's enough. There's more. No, we're not doing that. That's enough. All right.